All right, example 2 from 8-7 on special right triangles, where we have the bottom step of the Mosley's pool needs to be replaced. Well, that's kind of and the cost of the repair is based on the size of the step. Well, obviously, the bigger the step, the more it's probably going to cost. Makes sense? A side view of the step is shown at the right. So here's the step. Not exactly sure what that's a step, but either way, there's a picture there that we can kind of work with. FABD is a trapezoid. So this figure right here is a trapezoid with AB being parallel to FD. So that would be parallel to that. That's what makes it a trapezoid. And then FD is parallel to DB. So this is parallel or perpendicular, sorry. These two are perpendicular. So we have a 90-degree angle there. And we know that the distance from A to B is the same as B to D, as indicated by the tick marks there. And then AD is 12 inches. So we know that this is 12 inches right here. And we also know that FD is 18 inches, so that distance there. We want to round the area of the side of the step, so of this whole thing, to the nearest square inch. So what we have here is we have this triangle that is a 45, 45, 90 triangle, and we know that because it's a right triangle. That's 90 degrees. These two side lengths are the same. Therefore, it's an isosceles triangle, and as a result of that, these two angles are the same, which makes them 45 degrees, because all the angles have to add up to 180 degrees. The hypotenuse of that right triangle, so the triangle right here is the same one here, ABD, is 12, and since it's a 45, 45, 90, that is equal to x times the square root of 2. So however long this leg is x. That times the square root of 2 is equal to 12, because that's the relationship between the legs of a 45, 45, 90 triangle and its hypotenuse. So what we can do here is we can find the value of x by doing some algebra here. X times the square root of 2 is equal to 12. We divide both sides by the square root of 2. But once again, it's not okay to leave the square root of 2 or the square root of a non-perfect square in the denominator, because the square root of 2 is an irrational number. So what we're going to do is we're going to multiply 12 by the square root of 2 and the square root of 2 by the square root of 2. So we get 12 times the square root of 2 divided by 2. And 12 divided by 2 is 6. And 6 times the square root of 2 is the value of x. So that's what the value of x is. And that's not unlike example 1, where how we get from 12 over the square root of 2 to 6 times the square root of 2. Those two are the same value. And how we do that again is by multiplying the numerator and denominator by the square root of 2. If that's confusing, go back and look at example 1, because we did that same exact process to get from this to this. So that's how long this part is right here. So we're going to take that, AB, BD is the 6 times the square root of 2. We have that information now, and now we can find the area of triangle AFD. AFD is this triangle right here. The area of a triangle is 1/2 the base times the height. So there's the 1/2 times the base of 18. The height of this triangle from here to here is 6 times the square root of 2. We just found that out because this height is exactly the same as this right here. And just doing that mathematics, doing that multiplication, we get 54 times the square root of 2. Notice I don't change the square root of 2 to a irrational number. We're just going to leave it as a square root of 2. So the 54 comes from 1/2 times 18, which is 9. 9 times 6 is 54. So that's the area of this, and we're just going to leave that as the square root of 2. We're not going to simplify. I don't want to say simplify. That's not simplifying. We're not going to change that to a decimal, because this is going to be kind of a mess. So we have the area of this triangle, but then we need to find the area of the other one too, ABD, which is once again 1/2 the base times the height. There's the 1/2. The base is 6 times the square root of 2. The height is 6 times the square root of 2. That's going to simplify to be 36 inches squared, because 1/2 times 6 is 3. 3 times 6 is 18. And then the square root of 2 times the square root of 2 is 2. And 18 times 2 is 36. So we have the area of triangle AFD. We have the area of triangle ABD. And if we want to the area of the whole trapezoid here. We're just going to add those two together. So the area of the trapezoid FABD is the square root, or 54, times the square root of 2 plus 36. And then if we change that square root of 2 to a decimal by evaluating with a calculator, we find that the approximate value, it's approximate because the square root of 2 is an irrational number, it's approximately 112 inches